Alright, welcome back everybody. In this video we're going to look at some examples from the extreme values of functions lesson. We're going to start with example 1, determine the absolute maximum and absolute minimum values if any exist for each of the following. And these are all based off of the same function, y equals x cubed, which looks roughly like this. Okay. Are there any maximum or minimum, absolute maximum or absolute minimum values for this function on the interval from negative infinity to infinity? Well, in order to be an absolute maximum, it needs to be bigger than all the other y values that can occur. And to be an absolute minimum, it needs to be smaller than all the y values that can occur. And in this case, there are none of either, because I can always, no matter what y value I pick, I can always find a bigger value, and no matter what y value I pick, I can always find a smaller value. Alright, next, part B, y equals x cubed on the interval from negative 2 up to infinity. Well, now in this one, there is going to be an absolute minimum value. And the absolute minimum value is going to be the y value when x is equal to negative 2. And so we have an absolute minimum value of negative 8 that the function can attain on that interval. Alright, we can do the same kind of thing with this one. We go from negative infinity up to 3. In this case, there's no absolute minimum, but there is an absolute maximum that occurs, and the absolute maximum is the y value at x equals 3. It's going to be 27. In the last one here, we look at the function on the interval from negative 3 up to 2, and so we have both an absolute minimum and an absolute maximum on this interval since it's a closed interval. The absolute max is the y value at 2, which is 8, and the absolute min is the y value at negative 3, which is negative 27. Alright, so those are absolute maximum and absolute minimum values. Next we look at the extreme value theorem. The extreme value theorem says that if f is continuous on a closed interval from a to b, then f has both a maximum value and a minimum value on the interval. So if I draw any continuous function on a closed interval from a to b, there's a picture of when it's continuous, I'm guaranteed to have an absolute maximum value, which occurs right here, and an absolute minimum value, which occurs right here. Alright, so if I have a continuous function, I'm guaranteed those things. If I have a function that's not continuous on an interval, then I'm not guaranteed having both an absolute maximum and an absolute minimum. I may have neither. And in this function, there's no absolute maximum or minimum. Now, of course, it's possible for us to have an absolute maximum and an absolute minimum on an interval when the function's not continuous. It's just not guaranteed. Whereas when the function is continuous, it is guaranteed. Okay, let's keep moving along. Example 3, the idea of local maximum values and local minimum values. Absolute maxima also have to be relative maxima, but not the other way around. If we want to find the absolute extrema, we're going to go through a few steps in this process. First, we want to verify that the function is continuous on the interval from a to b. If it isn't, we need to be concerned with places where discontinuities exist. Then we need to find the critical points. And the definition of critical point is up here. That's where the derivative is 0 or undefined. We need to evaluate the function at the critical points and at the endpoints. So whenever we're looking for absolute extrema, we're concerned with two places. We're concerned with the critical points of the function and the endpoints of the interval. And then we're going to identify the absolute extrema. Let's look at an example of this. Example 3. Determine the absolute extrema for the following function on the given interval. So first of all, I verify that this is continuous. It's a polynomial, so it's continuous on the entire interval. And then I need to be looking at the critical points and endpoints to determine the absolute extrema. So first I need to look for the critical points. F prime of t here is equal to 6t squared plus 6t minus 12. I set this equal to 0. I'm going to go ahead and solve this equation. I can, of course, if I have a calculator handy, use my calculator to solve this, but I'm just going to solve it by hand if I can write the right thing down. It's going to be t squared plus t minus 2, which factors as t plus 2 times t minus 1. So the derivative is equal to 0 at t equals negative 2 and at t equals 1, and both of those critical points are in the interval. So to determine the absolute extrema, I'm just going to make myself a little table here with my t values and the value of f of t there. The places that I need to consider as candidates to be absolute extrema are the endpoints and the critical points in the interval. And so I'm going to find the value of the function for all of those y values. I think the easiest way for me to do that is going to be to go ahead and type this function into my calculator and then evaluate I'm just going to go into my table and set it up to ask, and then I can just type in the values that I want. So negative 4. And of course we're putting these back into the original function because we want to find the extreme values of the original function. Negative 28, positive 24, negative 3, and 8. Okay, and so the absolute maximum is 24, and the absolute minimum of this function is negative 28. Alright, so that's how we can determine absolute extrema. We go through the process. Is the function continuous? Yes. Then I'm guaranteed to have some extrema. If it wasn't, I need to look at where the function has discontinuities and consider what happens there. Then I look for the critical points. I evaluate the function at both the endpoints and the critical points. Best way to do that is a table, like I've shown you. And then from that table, I can identify the absolute minimum and the absolute maximum of the function. And these values, these other values, negative 3 is a relative minimum. It is smaller than all the values close to it. And 8 is a relative maximum. It's bigger than all the values close to it. But this problem, we were only concerned with the absolute extreme. So that's why I only identified these two to begin with. All right. That's the end of this video. Come back next time for examples 4 and 5. See you guys. Have a great rest of your day.